This lecture is going to be over the SSD technique for both the superficial and the electron beam. We're going to look at these two problems. Now you're going to have two problems just like this in the homework assignments, part of the quiz modules. And what you're going to see is, in the case of a superficial beam, how much time would actually be needed in order to be able to deliver the proper amount of exposure. And for the electron beams, we're going to be looking at the number of MUs that are computed. Now, the problems that you have in D2L in the course, they're going to have the numbers change around a little bit. Because of that, we're going to, the numbers that you see here are going to be different from what you encounter there. But that's okay because the principle will apply in both situations. So let's take a look here. So for a superficial beam, you've got a skin lesion that's to be treated using, obviously, a superficial beam. The prescription is going to be for 300 centigrade per fraction. The field size is 7x8. And the SSD is 50. The half value thickness, 2.5 millimeters of copper, and the backscatter factor is 1.123. The dose rate at 50 cm SSD without the patient present is 57 centigrade per minute. So what is the required time? So let's take a look here and we'll go through, get the annotation going. All right, so in order to figure out the time here, you'll need the prescribed dose. And that's going to be divided by the dose rate in air, multiplied by the backscatter factor. So here we have 300. That's what's given to us right here. That is going to be divided by the dose rate in air. Since the patient was not present and they measured the dose rate, this is what it is. And then the backscatter factor is going to be 1.123. So we put all of that information in. It's very important here to keep the units. What we're going to find out here is that as we go through, we end up with 300. And then you've got 57 times 1.123, which comes up to be 64.011 centigrade per minute. So since you have the amount of centigrade here and you have the amount of centigrade being delivered per minute, what happens is those two cancel and this comes into the numerator. So you take 300 divided by 64.011 and this is what you come up with. If you were to take and change this into seconds, obviously you've got 0.687 of a minute. And 1 minute is equal to 60 seconds. And if you do the math on that, which I don't have a calculator here, screen, so we'll take one using my handy dandy phone. So 60 times 0.687 ends up with 41.22, or since we're not good enough to be able to get a fraction of a second, that's what it ends up being. Okay, so we'll clear that out. Now let's go down to the electron beam and let's work through this one. All right, so we got an electron beam, an 8 MeV electron beam, which I don't know if anybody ever actually uses an 8 anymore. I've heard of 6s and 9s, but not an 8. An 8 MeV electron beam is used to deliver 300 centigrade at D max. The field size is 8x8. The SSD is 100. The dose rate is 1.0 centigrade per MU for a 10x10 cm field. The centigrade per MU for an 8x8 cm field is going to be 0.872. So what MU setting should be used to deliver the treatment? So the number of monitor units is going to be equal to the prescribed dose divided by the dose rate at the reference depth. And then that's going to be multiplied by the number of centigrade per MU at the treatment depth, and then multiplied by the, so that's supposed to be PDD. So here we have 300 right here, delivered at Dmax. We have 1 centigrade per monitor unit at our reference, and the centigrade per MU for an 8x8 field is going to be 0.872. PDD, since we're looking here at a treatment depth of pretty much maximum, is going to be 1.0. So we have 300, and then we multiply this down at the bottom, which ends up being just 0.872. Since we have, let's see, this is, let's see, okay. And this is this. Right. Okay. So we take 300 and divide it by 0.872, and we come up with 344 monitor units. So in this particular case, that PDD there is just going to be 1.0 because we're looking at doing this at Dmax. And so there you have it. That's for those two. I'll be adding some more videos here for other problems as well.